So I recently picked up this 3D printed SpaceX Starship lamp online. Now when I finally received it in the mail, I was a little bit disappointed to say the least. Some of the fins are very thin and brittle, two of which I broke off during the unboxing process and I had to glue them back on. When you go to turn the lamp on, the base glows, it pulses a little bit. It does look half decent, I'll give it that much, but it really doesn't do much else. It's not all that impressive. So I say we go ahead and build something bigger, better, and more impressive. Oh, and let's make it levitate. So we're gonna start our build with the central base piece of our lamp, and this was printed in a nice flat white filament color. If we take a look a little bit closer, you can see what's inside. So we have a DC to DC buck converter. It's adjustable, and it's gonna be outputting 5 volts. And the reason that it's gonna be outputting 5 volts is that we have a little Arduino Nano on the inside that runs on 5 volts. The LED strip running around the outside also runs on 5 volts. Now, this is not an official Adafruit NeoPixel LED strip. However, this comes from my local electronics store, but it's a clone. It's a cheap Chinese clone, but it's still based off of the WS2812 chip architecture, which makes this a RGB strip that can be individually addressed. Where the wires run into the base from the LED strip, there's some hot glue holding it in place, and that's just also providing a bit of a strain relief for those wires. Looking back on the inside where we see the buck converter, you can see that there's 2 wires running to the input, and those are coming from this particular plug here. So this is just a little power jack here, and this actually comes with the levitation module, which we'll get to a little bit later. But the bottom line is that I have 2 wires that I soldered to the back, and the 12 volt input will go to our DC to DC buck converter, and it's going to output 5 volts for the Arduino and for our LED strip. Both run on 5 volts. So that's key. You don't want to input 12 volts to those because you could ruin them. On the output of the converter, we have a 1000 microfarad capacitor here, and that's tied to the positive and negative leads on the output. And this is according to the NeoPixel Adafruit wiring diagram, which I'll put a link to in the description down below. And there's an explanation in that link as to why you would need that. But for now, you'll also just take a look at the fact that we have on the positive output, we have positive 5 volts running to our Arduino Nano, and we have a separate positive 5 volts running back out to our LED strip. On the 5 volt ground, we have that one of those running to the Arduino Nano, and we also have, again, 5 volt ground going to the LED strip itself. Other than that, the only other thing that we really need to focus on here is this particular white wire that I have running, and this is the data wire that goes from the Arduino to the LED strip to tell it what to do. And so the only thing that you can't see in that white wire is in line with it, there is a 470 ohm resistor that's in line with this white data cable, and that is on pin 6 of the Arduino Nano. And the reason that it's on pin 6 is that this is the default pin for the Adafruit NeoPixel library for Arduino, and so you don't even have to change that in the programming if you put it on pin 6. At this point, it's also a good idea just to plug in your input power to make sure that your LEDs work and you wired everything up correctly. In this particular case, I have already uploaded a program to the Arduino, which I found online, and it's a fire effect program. Now, if you don't have a program uploaded to your Arduino, I'm pretty sure everything on the LED strip should just light up white by default, and that'll let you know that it is wired correctly. Now that we finished the center of the base with the electronics inside, we can move on to the smoke plume. And so I've 3D printed the bottom half of the smoke plume in 2 parts. And I printed it in Fillamentum crystal clear PLA. And the reason I used the crystal clear PLA was because I did actually use a flat white PLA, and I tested it out with the LEDs behind it, and unfortunately the light did not shine through it enough. So I ended up going with this crystal clear PLA, and I think it looks great. Now, I've printed this in 2 pieces, split along this axis here, and the overall dimension, or the largest dimension, is about 280 millimeters across. And so if you have a smaller 3D printer, I also made these design files available that have been split in the other axis as well, so you could print this in 4 pieces. Now, for 2 pieces, There are also these little clamps here. When you sandwich them together in the same way, if you had 4 pieces and you sandwiched it in this direction, there are these tapered bosses sticking up here and here, and they have tapered clamps. So all you have to do is slide those tapered clamps over the tapered bosses, like so. And that's going to lock things in place here. So now it acts as one piece. And again, if you had this printed in 4 pieces, you just use these other 2 bosses, print 2 more of these, and lock it all in place. Now, from there, we can provide a little more stability to this model by also using these longer clamps that use number 4 by 1/2 long flathead screws. Now, these are high-low screws, so they're meant for brittle plastics. But basically, these little round-edged brackets here go face up against this side here, face up against this side here, and then the screws go into place. There's holes in the model for the screws, and that'll lock the clamps in place and prevent anything from moving further. So now we have our brackets and screws in place. You can see them there on this side and there on this side. We're ready to slip this thing on top of our base with the electronics, but before we do that, we just have to find the hole here where the power connector will slip through. So we're going to orient that with the hole in the base, which we have on this side here. And you'll notice that there are these tabs that go all the way around the base here, the center portion of the base, and they line up with some recesses in the bottom of this piece here. So this orients with where our power connector is coming out. So we're going to slip that through. And then if we can line up the recesses with the tabs, there you go. It'll drop down into place, and we are ready to now flip this thing upside down and screw those tabs into our bottom portion of our smoke plume. Looking at it from the bottom, you can now see 4 tabs screwed into place with those same number 4 by 1/2 long high-low flathead screws. And this is going to provide some additional rigidity to the whole piece here now that everything is sort of bolted into one solid 3D printed piece. Okay, so now taking a closer look at this thing as one piece, the final thing we have to address for this bottom is the power connector here. And as I mentioned earlier in the video, the levitating module that we're going to use comes with a DC barrel jack connector here. That's going to go in that hole. How this barrel jack connector works is it's got a jam nut, a very thin nut on the back that we can spin off, and we can pull through these connectors. And so if you're choosing a 2-pin connector, before you solder things together, make sure it fits through your nut. And now we can pass this through this hole here. Both connectors should fit, and that's going to slide in there just like that. And of course, we can take our nut, put it back over the connectors, and I'm going to thread it on the other side. I'm also going to use a little bit of hot glue just to make sure that nut doesn't come loose. Moving on, we're going to take a look at the top half of the smoke plume, and just like the bottom half, it can be printed in either 2 parts or 4 parts. In this case, I printed it in 4 parts, unlike the bottom half. And the reason for that was that I had a heck of a time dialing in this filament on my printer. The bottom half I could get away with 2 parts because it did not require any supports. The top half required supports and has a few more details like sharper overhangs that I was having difficulty dialing in on my printer. Now, as it turns out, after a bunch of wasted parts and wasted filament, this particular filament, so the extra fill PLA, and it's crystal clear PLA, requires very slow print speeds and the cooling fan running at 100% all the time, and that's how you're going to get the best results. But it took me a lot of tries to find the optimal speed to print this at, so you're looking at a print speed somewhere between 30 and 45 millimeters per second, depending on how good your cooling fan is. And so I was printing way too fast. I wasted a bunch of filament, but long story short, here it is, 4 parts. So to put these 4 parts together, just like the bottom half, there are these little brackets that I printed off, and I printed these in just regular white PLA. And there are holes in the corners here for them to bolt into. And so I have these tiny little number 4 by 1/4 inch long flat head screws. These are high-low screws, just like the ones we used in the lower half of the base. I'm going to be using these to screw together each of the 4 corners using these brackets. So I'm going to go ahead and do that, and I'll show you guys the result. With the 4 quarters now screwed together, you can see that this is one piece, but what I'm going to do is I'm going to flip it over upside down, and I'm going to use a hot glue gun along the seams to add a little bit more strength to this part and to take up those seams. Turns out that hot glue, when it dries in the same sort of transparency as this PLA here, and so it makes the seams very much unnoticeable when we do backlight it with our LEDs. So let's go ahead and do that. So looking at the bottom of this top half, you can probably barely see that I glued those seams with the hot glue, and that's because, like I said, the hot glue dries with a color and transparency that is pretty much at the same level as this PLA. So we're going to bring back the bottom half that we completed, and the next thing that we're going to do is we're going to find the little hole here in the top half of this base, and we're going to thread through our loose connector here that we have for our levitating module. And we're going to put that through that hole so it's sticking out. We can access it later. We're going to grab our hot glue gun, and we're going to glue around the edge here of this matte white base, and we're going to try and get some hot glue on a few points along the edge of this smoke plume, and then we're going to sandwich the 2 pieces together, obviously lining them up correctly and permanently attaching them. After some off-camera gluing, this is now a single piece part, and despite there being many seams, they're actually not quite noticeable at all. However, the big test is going to be when we turn the lights off and plug this thing in. We want to make sure that the light shines through evenly and we don't see those seams. So let's give that a try. And so there you have it. I think it does look pretty uniform. At the back of the lamp here, where there's that bunch up of wires, there is a little bit of a darker spot, but again, keep in mind this is going to be the back of the lamp, so you're going to be looking at it from this side here, where it looks nice and uniform. Overall, I'm very happy with this so far. Also, keep in mind that this is the test program that I'm running, and this isn't the actual final program for this lamp. And speaking of programming the LED base is pretty simple, and all you need is a USB cable and a computer. And so the base was designed to allow access to the electronics inside so that you can play with the programming and better visualize the LED effects at this stage of the assembly. It also allows you to access the Arduino for reprogramming with minimal disassembly later on, and you can also remove the Arduino to use it in another project in case you get tired of using it for this one. And so within the Arduino IDE, the Adafruit library holds an example for the NeoPixel strand and that you can see actually running right now. And you can build off of this example, or you can feel free to, of course, create your own LED effects if you have some experience with programming NeoPixel strips. And there are actually tools online that help you easily build code for displaying LED strip patterns, and I've linked to one of those in the video description. Now, since this is a rocket-related build, I thought it would be most suitable to have LEDs that produce a fiery, flickering, or explosion type of effect. And it turns out that some people online have already created something close to what I was looking for, and all I had to do was modify some of the parameters in the code to get exactly what I wanted. And I've created a GitHub repository of that code, and you can find a link in the video description. And if you don't have any experience with programming, not to worry, Adafruit has great learning resources to walk you through uploading your code and getting started with Arduino. I provided a link to the Adafruit learning resources in, you guessed it, the video description. Now that we have our desired program uploaded, we can take our Arduino and our hot glue gun. We can apply a small dab of hot glue down in one of the corners here and just set it down somewhere on the inside of our base, away from the DC voltage converter, and that way nothing gets shorted out if the base gets moved around. It's not enough glue to stick it down permanently, it's just enough to hold it in place, and if we really need to, we can peel it up later to access that Arduino. And now we can move on to installing the levitation module. And so this is the levitation module that I found on eBay. I'll put a link in the description, and this particular one can support masses of up to about 400 grams, and it uses a secondary magnet to do so. This base actually has quite a large magnet on it, so you're going to want to be careful with small tools and screws not to get them stuck to this thing before installing it into the base of our assembly here. But this is the top side, this is the bottom side. On the bottom you can see there's a white JST connector right here, and that is what is going to get plugged into for power, for just positive and negative power. So we're going to line up the connector and we're going to slide it into place, and it should clip in. From there, we're going to push in the excess wire and line up our mounting holes. Might have to wiggle this around a little bit. There we go. And line up our mounting holes. The module will mount to our 3D printed base with some number 4 by 1/2 long flathead cap screws. So the only piece missing now is the landing pad. And you can see here that I designed a landing pad inspired by a real SpaceX landing pad with the inscription at the bottom, just read the instructions. And so this black portion of the landing pad was printed in black PLA from eSun, and the white inlays were printed with some matte white PLA that I had laying around. On my piece here, the white inlays actually snapped into place, but if they don't snap into place for you, you'll just have to use a little bit of super glue to get them to set in there. And the inscription was done with silver pen, and I just used a fine tip silver pen to get those letters because they're too small and too fine to do with inlays. And you can see here that there's a little tab to line up the landing pad so that it's always facing the right way when you go to use this particular model. And so we're finally ready to take a look at the Starship model, and you can see here that I've printed it in 2 halves. So the bottom half was printed in this orientation, so this flat side down, and the top half was printed in this orientation, this flat side down here. Now this is actually the easiest part of the build, and it's certainly not rocket science. The original model was provided to me by a guy named Nick on Thingiverse, and in the description I'll put a link to his original model in case you want to print it in a solid format. But for me, I had to print it in spiral vase mode. And the reason for that is when you do actually go to glue these 2 halves together, the rocket is quite long and it ends up having a very high center of gravity. And when you're trying to balance this thing on a magnetic levitation platform, that high center of gravity tends to make things want to tip over. And so by printing it in this spiral vase mode, it's completely hollow, it's very thin walled, and therefore the center of gravity isn't too high because the magnet of which everything floats on is quite heavy, and this will be at the bottom. And so when this thing's at the bottom, the center of gravity shifts down lower and it's able to balance quite nicely. After gluing the 2 halves of the Starship model together, we're going to take a look at one of the final pieces here, and this is the thrusters here on the bottom. And this piece I designed so that the levitation magnet snaps into place inside of here. And on the bottom, you'll see these kind of little thruster looking things with these red LEDs in them. So I'm just taking on a little bit of an additional challenge here to try and make these things light up and fit it all inside of the Starship model. So I have 3 resistors here, and they are 100 ohms each. One end of each resistor ties back into the positive lead, which will go to the battery. The other end of the resistor goes to the positive lead of each of the LEDs. The positive lead gets bent up and sort of along the wall of this piece here that's going to grip onto the magnet. So that goes back to, of course, the resistor that I just mentioned, and each of those is fed with 3 volts from the CR2032 battery. Now the negative leads on these LEDs are a little more unique. I mentioned earlier that I'm going to be using the body of the magnet as a common ground, and so it's a little difficult to see inside, but I bent those legs up and sort of inside the channel, a circular channel that you see in there, and they're going to be touching the magnet when I snap the magnet into place, and therefore only one of these negative leads has to come up and back over top of the magnet in order to get to that battery. So I soldered a little wire on that, and that's going to be the ground wire. Once I get the magnet inside, we can test it out on a battery and see if it works. Okay, so I have the levitation magnet here and I have our thruster piece, and I'm gonna try and insert the magnet inside, and we're gonna see if we can do that without breaking anything. So it looks like it successfully snapped into place and none of the plastic broke. I'm gonna go around the outsides here where the positive leads stick out. I'm gonna add a dab of hot glue in there, and I'm gonna move those leads away from the magnet and make sure they don't short out on the magnet. Then we can test out the little thruster LEDs and see if they work. And so you can see the dab of hot glue there inside the channel to prevent shorting of the positive LED to the magnet body. And now that we're done that, we're on the home stretch here, and we're going to address the coin cell holder. And so as I mentioned earlier, this is a little coin cell holder for a CR2032 battery, and this guy comes from Adafruit. Now I've already bolted it into this piece that I designed here, but you can see the little battery in here. Over here you can see the leads, one's a switched positive, one's a ground, and the other one's an always on positive. And the little switch can actually be found on the side of the PCB here. Now I had to sort of hack my way through this because I forgot to make a little channel in there to access the switch. And again, that's a little hard to see with the lighting, but the switch can be accessed with just a flat tip screwdriver, and I can turn the thing on and off through there. The final model and final version of this piece on my Thingiverse page will of course have this slot modeled in, so you guys don't have to hack your way through the plastic. But you can use 4 tiny screws here. I just used some number 1 screws. I think they're about 5/16 long each. And I've bolted that down to this piece here. On the back side, there are 2 more screws. These are just flathead screws. These were number 4 screws, and they're a 1/2 inch long. I just used whatever I had from earlier on in the project. And these actually don't attach to anything. You can kind of see them poking out here. The purpose of these is that this guy will sit on the face of the magnet. And it turns out these screws here, if this will come back into focus, these screws here are magnetic, and so this will just sit nicely on top of our magnet, and everything is one nice unit. And all I have to do is connect up the positive and negative leads on this piece here, and we have our thruster unit, and we're ready to shove that into the bottom of our Starship model. But of course, first we have to test out the LEDs to see if they work. So I'm going to throw the negative lead on the ground terminal. I'm going to throw the positive lead on the always on terminal just to test it out. And it looks like a success. We have 3 LEDs powered up on the bottom here, and that should cast a nice red glow onto the landing pad. So lastly, we're going to do the final assembly of the Starship model, and we're going to start by turning the rocket thrusters on. So you can see here that they're on, and now we can take the body and we can slip it over top. And this thing, as I mentioned earlier, is a spiral vase print, so it's got a little bit of flexibility to it, and we can slide it over top pretty easily. Now there's also a shoulder on the edge of these thrusters, so it can't get lost in the body. It does stop there, and now our model is assembled. So now let's see if we can take this thing over to the landing pad and get a successful levitation. Okay, so we're finally ready to test this thing out for the first time, and the first thing we have to do is turn the base on and see if it's working. So of course the lights come on, everything looks good to go. We're ready to take our Starship model, and we have to carefully place it right perfectly centered in that magnetic field. And if we get it correct, then look at that. It does levitate and it does work. We're going to turn the lights off for a maximum effect here. And you can see the beautiful LED effect of those NeoPixels in the base, making it sort of look like the rocket is working and landing. You can see the red glow on the landing pad from the thrusters, and it's actually lighting up that SpaceX symbol in red. That's pretty cool. Take a look at it from this angle here, and you can definitely see that it has some height to it, and it's floating. At this point, I'll leave you guys with some footage of this thing in action. Now these projects take quite a long time to design and build, so I'd really appreciate hearing some feedback from you guys in the comments section, and I would enjoy it even more if some of you guys took it upon yourselves to try and build one yourself using the links that I've provided in the description. And if you guys are feeling extra generous, you can now make a small donation to my channel using the Buy Me a Coffee link in the description down below. Your small donation goes a long way in helping me pay for these projects, and it's a huge morale boost for creators on YouTube knowing that people care enough to contribute back. Thanks for watching, guys.